he put the engineer, how if you do not put this beam, it is like floating. So basically, uh, people, when an engineer design, it should be different to the bus or a non-engineer. So it should be, so basically we should be able to design, also architects like to make the everything floating, anti-gravity, right? So you should not, the design should not be obvious. Now, if you look at this scheme, you cannot even see a beam. Maybe you use this parapet wall to support the slab. Okay, so it is not a load, but it's a member. So I'm trying to again convince you all how to think about a particular design. So this is, we have to have a seamless design. Seamless design. This is my advice. Okay, let's go to the next one. We'll look at a particular scheme that I have designed and try to understand. This is a multi-story building, designed for as a private university. So architects, there are a few floors, 1, 2, 3, 4, 5, 6, 7, 8, and a roof slab. And there, this is since this is a private university, there are lecture halls, there are laboratories, etc. And so there are car parks underground. We need to make sure that we have enough headspace to do that. And we have to look at, now last time I discussed when I'm talking about the space. Generally, let's say I always advise not to take a beam more than 600 millimeters. That is for the structural height. We need structural height should not be more than 600. For multi-story buildings, mechanical require height will be around 600. And then you need to have a minimum of 2.4 meters. So the total building height, building floor to floor height, should be minimum of 2.4 plus 1.2, that is 3.6, right? So if you reduce, now say instead of beams, if you make it a flat slab, then you can reduce your structural depth to about 300. So you can reduce like 1 feet from this thing. If you let's say you are doing a 50-story structure, if we can reduce 1 feet from one slab, we can save 50 feet from the overall building height, which is a huge saving. It's a huge saving. So when we design a multi-story structure, we have to, the main problem is the cost. So we have to reduce the cost. One way is to reduce the cost is to reduce the building height. Okay, building height, while providing the required space for services. So basically, as structural engineers, we have to play within a particular structural depth. So this is the car park. So when you talk about car parks, if you put a column here, column here, column here, column here, then you will reduce the number of car parks. According to my knowledge, now when you design a car park with the circulation is generally around 60% of the floor area. One car cost around 4 million rupees. So if you reduce one car, you will reduce 4 million rupees from the developer. Okay, the capacity reduces. So basically, when you look at uh, the scheme, you have to maximize the column spacing. Okay, so if you try to think uh, to reduce the slab or the beam and try to put columns at every 10 feet, hardly only one car can park. You will lose couple of car parks, right? So the way we think with respect to multi-story buildings is completely different from a house design. Completely different from house design, right? So basically, uh, and also we have to understand there are services. So services can be utilized, put where you cannot park cars. Then you have fire staircases. You know, the fire requirement is minimum you have to have 30 meter. Every 30 meter you have to have a fire staircase. Fire is a very important aspect with respect to the basis of design. Then you have uh, passenger lifts, you have fire lifts. So if you have fire lifts, you have to have specialized chambers where you have to cover the whole, we have the inside, you have to have positive pressure, right? Generally, when you have a fire lift, you have to have a concrete core, right? So if the multi-story structures are like 4 stories, you can have columns to support the lift. You don't need a core. But if it is there's a fire lift, you need to support. And then you have pump rooms, water tanks, toilets in the basement level. So if you have toilets in the basement level, you are below ground. So you have to pump the sewer. So you need to have a sewer pit below the this things. So everything we have to think about, because architects are designing the building, they don't know about structures. MEP people designing the MEP services, they don't know about structures. But we, as the people who are going to construct the structure, should incorporate all these services within the architectural spaces given. So when the services are given, we have to properly organize so that we we increase the we increase the uh, buildability. That means we should make sure that uh, we 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 propose to the architects and the mechanical engineers that if you have a water tank, now anyway we need lift pit, put all everything very close to the pits. Don't try to put very close near huge excavation near to the neighbors' houses. Okay, so those are the things that we need to think about. And when there's a basement, we need to have a retaining system, which we need because we have whatever happens, we have to protect the neighbor's property. Otherwise, you will get sued, right? So, and also when we have a basement, the water can come in. We have to have a stormwater discharge systems. We have to propose to the MEP engineer where to put the stormwater discharge systems. We have to incorporate pits to collect this stormwater and pump it out. So a lot of things than the MOBD squared and 100 days OBD to find reinforcement, right? So this is where the engineering is. That is the truth. Generally, scheme design is done by very experienced engineers who has built buildings. So they will know exactly what to come. Otherwise, MEP engineer will remember that he has to increase the sum capacity. He will say we need to increase the sum capacity. You have to redesign the whole building. If you don't know, if you do not know how to know if the MEP engineer says I want a stormwater, then he will come and tell you, and you have to redesign the foundation. So a lot of repetition work. So generally, when you do a scheme design, we have to have a checklist. Checklist will you have to check, okay, whether there is enough space to park cars. So what is my column size? Whether pump, water tank, they have provided the sump. Whether there is a sewer sump. Whether the lift pits fire lift can take a stretcher, right? Then whether this fire staircase is enough, right? So we need to know the regulations and whether this whether this site is going to get flooded. Okay, currently I'm designing a building. Every year it is getting flooded. It is very close to the Kalani River. Every year the flood there will be flooding, and it's a tea factory. It is about 1.5 meters flood level. So all the design we need to provide above the flood level. All the MEP services should be above the flood level, and we need to design a stormwater system so that we have to pump it out when to the river, and we have to have gates like flood gates at the entrances so that the water doesn't come inside. So we need to. There are a lot of complications than the laws that we have to talk about. Like basically, so the scheme design is the very important aspects. And when you go to upper floors, you have many options to have, now say for instance, the column positions inside a particular function area. Sometimes architects will say you may have to remove. Then you have to put a column here and put a transfer beam and transfer the column at an upper level. So many issues when we go try to look at. And then we have to, then there are toilets. Sometimes toilets you need a level drop because and then we have to think about it. And sometimes they ask for a level drop of 300 millimeters so that they can put the pipes later on. Most of the time what they do is they don't design. They ask us to keep a drop so that they can put all the pipes and then concrete. So we have to do all that. Actually, sometimes, most of the time, I think in other countries, they allow the services to penetrate below, even it is in an apartment. In office, we can penetrate, do the services below, and then sometimes we might need to give an opening inside the beam in order to facilitate the sprinklers or air conditioning duct. So many things that we need to coordinate with our counterparts in order to realize this building. So there can be openings for architectural reasons. We cannot argue with the architect. And the balconies, right? And then from the balconies should be sloped, otherwise the water will come inside. So many things. Toilets should be sloped, roof should be sloped. So let me go forward. So before you do any calculation, we need to come up with a scheme. Okay. So based on the soil condition, the adjacent neighbors issues, we need to have a retaining system. You can see I have and timber planks. That can be done I will come to that in detail. If your water table is very low, if the water is above, we might have to have a retaining system so that water cannot come inside. So because we need to have a dry system. And you can see I have provided, this is a raft slab, and I have provided catch pit to collect water. And there is the lift. We have to have a lift pit. There will be services. And then the columns, you can see the column sizes. It's around 300 by 400, 800. Now, generally in a car park, my advice is do not do below 300, because if there is, let's say, if the car knocks on the impact on there's an impact from the car to the wall, the column, you might you might damage the part of the building, right? So generally, I would say you not to reduce more than 300. So because it should have some inertia to resist the forces. So you can we will see further. So these are some of the sections. You have to have a waterproofing details. These are waterproofing details. And then you have to show a buildable system so that contractor can price. So most of the time, the consultants do not show what your intention, how to build. If you do not show how to build, then contractor will miss, obviously, because they are given a very short time to, and then there will be a lot of claims after that. So here, what I have done here, if I draw it, like, okay, I say, okay, you have to put a retaining system. What I propose is this thing, and then I put block work to receive the waterproofing because it's a negative waterproofing, and then we put a screed, and then against this block work you put the waterproofing and the protective screed or whatever, and then you put concrete. So this section we need to draw. How the boundary wall is because if you miss any detail, contractor will omit the pricing because even the QS will also omit these details, right? So good practice is to show everything. How do you thought of building this building, especially the underground? Sometimes, let's say you have a catch pit. Then if you assume that if there is a service underneath, you need to take this pipe and cover it with concrete. draw everything, every section, how you think you're going to do it. Okay. So the slabs beam systems. So we will be discussing more on these axes. So you can have you can have two-way spanning slabs, one-way spanning slabs, flat slabs, piece slabs, many options. So based on the span and the load, we have to select a particular option. Or you can do with this with steel, and you can do with composite. So many options are available to you. So here, these are some of the details I would like to recommend. Where inside the toilet, before before we build the brickwork, I would normally recommend a 300 or 200 millimeter curve with concrete. The reason is then you can put the waterproofing here. If you even in balconies, I do the same thing, so that water will not leak through this big joint, brick and okay. So these details are very important details that we need to uh, follow. You can see in this, you can always in my drawings, I have two lines. I always say you cannot have one line. Okay, it's like God is meant to have two always, right? So always we need to have two lines. So uh, when I see a particular one line, I know there is something missing. So always engineers, architects uh, talk with lines. Every line has a meaning to us. So we have to show all the drops, etc., etc. And when you come to the roof, you need to slope the roof with the concrete, right? Sometimes you can have a level difference between the edge and the maybe 2 inch level difference. Nobody will hardly see this, but during construction, we can have it, and you will solve 100 problems. We should not always depend on the waterproofing. It is only a, yeah. So we should make sure our structure is watertight. So this good detailing practice will help you to eliminate these eternal problems. You know, people will curse you if there are a lot of problems in their buildings because they pay you good money. Okay, so this is a temporary earthwork system. I used to give this to the contractor because most of the time the contractor doesn't have qualified engineers with them, uh, and and also when they are pricing, they can consider all that because they have to price very first. Hello. Hello. So this is these are called dewatering press. If there's no groundwater, then storm water will be there during the construction. We need to capture this storm water and pump it to a common pit and pump it out. So these details are given in my drawings so that contractor can adapt them during the pricing, and also if they price, we can insist them to follow these drawing. They don't need to follow exactly this drawing, but they have to follow their proposal similar to this. The idea of having these ones is when the water comes from outside to capture that and then transfer to the center, and from the center you can transfer to a pit, and from the pit we can dewater. So I am not going to talk about much construction, but I will talk about how to think about mainly focus on the scheme design. Now, obviously, after you get a job, you will first uh, go and do the site investigation. When you do a site investigation, please go to the site. Most of the sometimes my engineers, when I give them this thing, they depend on the site investigation report and do the structure without even going to the site. That is not a good practice. So basically, when you go to the site, you can see the sample. When they are doing the site investigation, you can see the sample. You can get a feel. Design is all about the feel for the loads, materials, and about the earth. So the best thing is you have to have a feel. Most of the time, we depend on the computers, but we do not depend on our own brain, which is million times faster and also million times uh, efficient uh, machine. So when you have a feel, your common sense judgment is much accurate than the computer simulation. So therefore, when you go to the site, you will see there's a building. So we can advise, if you are cutting very close to the building, architect to change. Otherwise, we would design, and then when you go to the site, you see a building, right? And then if you are doing very close to, then we have to investigate what is the foundation of this building, what is the depth of their building, what is there is if there is the basement. If there is a basement, take the permission and go and see the basement. Talk to the structural engineer, see whether what is the foundation that these guys have done. Okay, so if let's say if say a similar building they have done with raw foundation, if you propose pile foundation, then client will go to consult this engineer and go to him. So therefore we have to be wise. And in the other way, if they have done a piles, and if you are proposing a raft, that also questionable, right? So we have to be very. And the water, whether it's getting flooded, what is the water table, right? And the logistics, whether we the concreting, whether we can do it day and night, what are the adjacent buildings outside. So many things that we need to look at, and also the samples, of course. So generally, when we do a site investigation, most of the time we get the services of a geotechnical consultant. So there are so many geotechnical consultants and contract geotechnical firms here, geotechnical firms, big names. When you just ask, uh, let's say you ask her, give me a site, I am going to build this building, this tall building, and very close to this place, and you can show the site, and you ask for a price. So you don't know how many boreholes they will put, how depth they will go. It will depend. It will depend on different uh, perception of that particular firm. It's a Therefore, basically, if you want to get an apple-to-apple comparison, we have to give a site-specific specification or building-specific site-specific specification, right? To do that, you need to have a good idea of what is site investigation is all about. So here we have introduction to the building, and then we have field investigation, laboratory testing, geophysical investigation survey, that is with respect to the to see whether there are underground problems, because we don't know until this results come, whether it's a pile or a raft foundation. And if there is if you are doing a seismic design, you have to classify the seismicity of do a seismic survey classification, which is will tell you the liquefaction potential of the soil. Hydrology survey to determine the design of groundwater level and the corrosiveness of the groundwater. There can be harmful chemicals like chloride and sulfate to the and here we specify what code, because different codes will give different interpretation. And we propose the number of boreholes. Of course, given the, we can also give the give them to propose the boulder, but for the specification we put a particular borehole. Then we look at the field trials, that is field permeability test, very important. That is useful not only to us. Permeability is very important to see how much the seepage levels of this thing. If the permeability in the range of 10 to the power 7, that is impermeable soil. So you don't have to worry about the permeability. If it is in the range of 10 to the power minus 3, then it's very permeable. Maybe like sand. So you need to, from those information, you can get an idea about the retaining system that you are going to adopt. Standard penetration test will tell you what is the strength of different layers. Consolidation test, if you want, you can undisturbed samples, you have to specify. Then the laboratory testing, chemical test, and also the geophysical test, everything we can specify. So this is the seismic test, especially the liquefaction potential. Unfortunately, liquefaction potential we don't have in Sri Lanka. That is called shear velocity test, and but they give when you put it, they will give some interpretation based on the SPT value and hydrological survey and the interpretation report by a qualified person. So when you do all this, you will get here the borehole map. So this is actually a high-rise building, and this is the podium area. In this area, we have said this is type 1, number of boreholes 10, and number of boreholes 5 meters in RQD more than 70. So this area, we are saying to the contractor, you have to go 5 meters more than the 70 RQD. Here only it's only up to podium. It is about 10 stories. We have asked the contractor to go up to 2 meters beyond the 70 RQD. And then we give like a BOQ where they can price. So we should now say if there are 16 boreholes, that means every borehole we have to have a one test sample of for natural water content, right? So bulk density. So likewise, we can here for the rock we have 32 numbers, so they can price, and when we can compare. Otherwise, especially in government sector, if you get a low price, if you get a low price, they don't look at the, because you have not asked for the specification, and they will put one or two boreholes and give interpretation and go. So you cannot select the best person. So basically, I will give you a rough idea about the soil capacities, because as engineers, we should have some idea about the soil, because we should not just blindly accept the recommendation of the geotechnical engineer. Sometimes you might have experience. You see some of you feel you have done buildings before uh, considering higher bearing capacities, while the new generation geotechnical energy give very conservative values, where the cost of the foundation goes very high, and client will not build the building. No, our objective is lost. So basically, if it is sandy soil, it should be around 100 to 125. Clay soil, 75 to 100. If it is Cabot soil, 200 to 250. I have done one building in Jaffna, that is and east also I have done building. Jaffna I have done one building, open university building. There I noticed the noticed it's very hard limestone. So you also can go up to like 250 kilonewton per meter. Only thing what I found is it's very shallow. My advice is at least you have to have 600 millimeters below the ground, because there might be drains, etc. So minimum depth, even though you have a very hard soil there, sometimes you should at least go beyond 600 millimeters to place the foundation. Never place a foundation on a peaty soil. Peat is like a very soft soil. Soil, if you look at the soil analogy, is soil particles, then air particles, and water. So when there is pressure, the water will evaporate, and then water will go, and then this will settle. So basically, peat is like a sponge. It is made out of vegetable matter degraded for million years. So it is like it will settle very, very fast, because even a 25 millimeter relative settlement in a building will cause you a lot of cracks inside. So always consult a geotechnical engineer for advice. Although you have some previous knowledge, and also we have learned in the universities, but we need to consult specialists on this subject. Society investigation on another project where it's also high-rise buildings. Generally, SPT values are done. Sometimes there may be young engineers who has never seen an SPT test. For their benefit, you can see this video where this person is marking 150 millimeter distances, and you have the standard test which is going to be dropped a specified height, and by looking at the penetration and counting the numbers, we can get a standard penetration test. That is the stiffness of the rock. So you can see here, if the numbers are high, these very high numbers, more than 50 is very, very good. Here you can see some values are below 10. So with this SPT values, we can see the stiffness of the capacity, bearing capacity of the. As a thumb rule, let's say you have SPT value of N is like 10, then your bearing capacity is 100 kilonewton per meter square. But if you have water above your foundation level, you divide by 2, then it becomes 50 kilonewton per meter square. So likewise, we should have some idea about the rock. So side parameters now they give even the E values, because we need these E values to input to our computer software, and also allowable skin friction is given. Skin friction in a pile, skin friction is the friction generated by the soil, which is going to support the pile to carry the loads. So generally, what I do is allowable. My experience says, if the SPT value is N, your skin friction is N kilonewton per meter square, allowable. So let's say whether my theory is correct. Let's go back. Let's say this is soil. It is 21. If you go, so that layer is around 15 to 25, so almost closer to the SPT values. Okay, so then we come to the rock. How to, as a structural engineer, how do you think about rock? Okay, so we think rock can take infinite capacity. It is not so, because rock is weathering. It's not. We won't get 100% intact rock underground, right? So when you take a sample, if you take a sample, so you will see there are intact rock, there are small pieces like that. Say you take a 1 meter sample, and if your spool is full, or it only 90% of the spool is recovered, then the core recovery is 90%. So if you say it is good, yes, it's good. You have a good number. 90% is always good, right? If it is, let's say, core recovery 20%, yeah, Not so good, right? So similarly, there are intact rock. So the code says if you can calculate the percentage of pieces more than 100 millimeters, we call it rock quality designation, RQD. Very important number, right? So RQD is about number of pieces in a 1 meter sample more than 100 millimeters. So if it is, let's say, if it is 100, 90, very good. If it is 20, very bad. Okay. So based on that, you will get the allowable bearing capacity of the rock. Okay, let's look at what the geotechnical engineer has given. Now the geotechnical engineers are very good. I mean, this especially this professor is a very good one. So you have they have like so he has gone to very depth and every category he has marked. I just wanted to for you all to understand what is this. Now in this also you can see grade 3 rock grade. Let's remember this grade 1 grade 1, no apparent weathering, clean rock. So grade 1 is very good, right? It's like 100% RQD. Let's go and see to our now. Let's see. Now this is core recovery. This you don't believe me, again I will show you. Here core recovery RQD. First column core recovery RQD. Now you can see core recovery is 60%, RQD 0, highly fractured. Here highly fractured, then it goes to 8, 29 increase. For me, I will tell you, RQD is very important to me. If it is more than 50%, it is good. Now let's see. Now say this is grade 5 rock. According here, maybe grade 3, maybe grade 2. Let's go to the, I don't know, I can't remember the classification that he has done. He has classified the rock into several grades. Now, here you can see with respect to the allowable friction in good rock is very high. Sorry, we have to go to the next one. This is the rock. Okay. Allowable friction in grade 1 rock is 200 kilonewton per meter square. Allowable is grade 3. It's around, that is 100, right? And with respect to grade 1, that is 100%, you can take 8,000. If it is grade 3, 4,000. Grade 2, 5,000. Generally, I will give you a ballpark figure, which I normally follow. If the RQD value is greater than 50%, you can take 5,000. If it is more than that, let's say 75%, you can take 6,000. Generally, although there we get this, I do not use this. This is the maximum value I normally use. If it is less than 30, we take 3000. We do not take less than 3000 also, because rock is rock, right? So it may be fractured, but generally most of the code says you can take 3000 for with RQD. There is here good. You can see the definition, core recovery, total length of rock recovered, total core length. Then sum of the length of sound rock greater than 100 pieces from the total core length, right? So there is example here which you can read. Here, good. You can see the core recovery and RQD. So RQD 29 is a grade 2, 3 rock. 47, that is where he has given like 4000. So after, I mean, this is a very good recommendation. You can see, look at this, grade 3 rock, RQD 36. You can see here it's a very good rock. You hear about 100% RQD, right? So when you take a borehole, you get the weathering is not mainly when if you are a consultant, you have to have understand about this about the soil. Now, say for instance, if you stop the pile here, your bearing capacity is low. When you stop the pile here, this is a sound rock. It can take a long. If you ask them to go beyond this, it will take a long time, right? So you can stop the pile here, although you have weak rock down. If you ask the contractor to go 2-3 meters in this rock, he will break all his equipment. You can see the rock quality of this. You can penetrate. Now, say for instance, the penetration rate of a piling rig here is around, according to my experience, is around 2, 3, maybe 10 millimeters per hour. Here, more than 1000 millimeters per hour. So you should not stop in this one. You can see the soil is here, and then you can see a boulder, and then you get fractured rock here. So this is, we need to understand, if you have boulders, you have to be very, very sensitive. So you need to properly map these contours. You can put that into a software. Here, one of our projects. Before we do all this, we have, with the data that we have, we were able to map the exact, I mean, not exact, but very accurate rock profile. So rock is not flat. It is also weathering is there. And this is how actually we get rock. So foundation type, what type of foundation you use? If it is a raft foundation for a multi-story building, you can have flat raft. You can have raft with, in order to satisfy the shear, we can have only a drop raft at the column, like a column head. You can have a beam raft. You can have upstand beam raft. Okay, or you can have a like a waffle raft. Now, all these options are very nice. It theoretically, you might say this may be the the cheapest option, and it is the most complicated to design. If something is complicated to design, it's very complicated to it is very complicated to construct also. Okay, so complicated design is not the thing. Buildability is the key to design. I always go for this option. Okay, little bit concrete more, but very fast, because underground work takes long time. You have to come above ground, and we don't know what's going to happen with the Sri Lankan rain condition, neighbors condition, political condition, COVID condition. You know, COVID, you get COVID, and they stop the this thing, and then you have to dig down, and there will be rain, and the whole thing will collapse. No, not, we don't know exactly what is going to happen. So make it simpler to the contractor as possible. Underground work, fast as so you always try to come very fast out of the ground. Okay, so generally underground work will take about 6 months of the construction time. It's almost 1/5 of the construction time. So very important, we need to focus on this. It is not, it is the time is your design criteria, not anything else. Okay, so don't make the contractor's life is difficult. Make contractor's life easy. You will build many buildings than one building. So there are many methods to many design. We normally use the beam on elastic foundation principles, where we use a subgrade reaction. Subgrade reaction is based on the bearing capacity given by the uh, by the geotechnical engineer. So I am not going to talk about all these today, where I will be mainly focused on the geotechnical scheme design. So you can get all the bending moment shear forces. After you get the bending moment shear forces, you can calculate the reinforcement. So basically, one thing I want to tell you is, even when you're putting the reinforcement, make the lives easier. Now this is another soil test. You can now not only that is earlier one I showed was linear analysis, where you have the raft, you can get analyzed as strips in both directions and analyze as a 1D element, or you can analyze this as a 2D element. You have a lot of software these days. A lot of softwares are used and misused by our engineers. So if you know, it is it has a, if you don't know about it, it is a disaster. So basically, when you detail, uh, you have a common reinforcement top and bottom, and then at the stress areas you can have additional reinforcement. So that is how you have to detail a raft. I will go a little bit. Am I going faster or slow? I'm slow. So basically, you can get the bending moments. You can get the bending moment. If you know the bending moments, you can get the reinforcement. Okay. Any question after that? If there are no questions, I will go forward.
If there's any questions, I think you can put in the chat box, or if anyone want to ask any questions, you can raise your hand. Then we can allow you to unmute and ask the question. If there's no question, I think you can continue, sir. I think if there's a question, right, please raise your hand, then you can ask.
Right. So if you are doing, I mean, basically any multi-story building, you will have at least 1 or 2 basements. You need to have a retaining systems. So if you have an existing building, we have to be very careful because this here it is held by the soil and the water and air. So let's say you have a water table here. In order to do that, you draw down the water like that. If you draw down the water, then the water will go from the soil matrix, and there will be increased pressure on the soil, and these buildings will settle, and there will be cracks on the buildings, and there will be litigation against you. Okay, so these are very common things in Colombo. So this is what happened in China actually. So they dig a pit very close, and these are on piles. When people think when you have piles, you don't have to worry about it. There's a lateral pressure and building collapse. If somebody dies due to the building collapse, you are dead and gone. No, in Sri Lanka, you can be you can take you can will be in prison to life under section 298 of the criminal code of law. Okay, so better read that. So we have to be very careful. There are many softwares to analyze. You have to look at the water pressure, soil pressure, surcharge loads from the buildings. Generally, if there's a building, now say if there's a building here, if there's a multi-story building, let's say that is in a so generally when I'm doing building, we have to consider about if it is on piles, not much lateral force, but if it is on a shallow foundation, we consider about 10 kPa load on foundation per floor. So if there are four floors, it's around 40 kPa. Now recently we did a project. Then there was a reviewer from the university. They told us you have to take at least 60 kPa for the this thing, and we checked for 60 kPa. The logic was whatever you do, we cannot assume that we have a raft. If we don't have a raft, if it is on a small strip foundation, then it will carry around 60 to 80 kilonewton per meter pressure, very close to this. So basically, we check for 60 kPa, even though it has only 4 stories. So today we have a lot of software like Plexis, Geo5, many other softwares to analyze this problem. So when we analyze, we first model the soil, and then we simulate the actual excavation and starting levels. And this particular project that I'm talking about, the reviewer asked us to simulate the unpropping action also. This is the surcharge load. So very important that these software is very good for us to really simulate. So these are the traditional retaining systems where steel chines and timber planks. If there is no water table, we can use it. This is a truss block that I have actually designed where, in order to avoid huge concrete volume. And here, if there is water table, high water table, we need to have sheet piles. The problem with the sheet piles is if your SPT values are more than 10 or 20, very difficult to drive. So you need to pre-drill before you drive. Otherwise, there will be huge vibration and a lot of people will get affected. And other option is to have secant piles. Both piles, secant piles are piles like you have to very. There are two female piles without reinforcement, and then one male pile with the reinforcement. Sometimes you can have all piles male reinforcement based on the load, and these are called secant piles. You don't have a gap between them. These are called boat piles where you have about 75 millimeter gap, and then finally you have to grout it in between, otherwise the water will come. This is a sheet pile wall starting, and we have excavated here about 18 meters very close to the Bere Lake, and it was like a real difficult structure here. Again, this one is a retaining structure that we have designed, and it is anchored to the soil. If you can remember correct, Mr. Kirivaran is the one who designed the anchors. So we need to monitor the deflections, and if we have to monitor the deflection daily basis, and also monitor the water table, and also if there are truss, we have to monitor the stressors, and we have to set different limits like level 1, level 2, level 3. We say alarm limit, action limit, etc., etc. This is like a guide for the. This is called a torpedo, where you insert that, and then you can get the reading of the deflection in both direction. Substructure. When you design a pile foundation, of course, pile foundation are designed based on the loads. So if it is maybe the perimeter, the main thing is you have to in a pile foundation, maybe let's say you have a couple of rafts, basements, and some other piles at the edges. You have a, let's say you have a load here, you have a pile here, and some of the corner piles are put in order to hold down the corners from the upthrust. So upthrust is a major problem when we have a couple of basements. So you need to have something. And also during construction, you can do part construction. So you need to understand. So otherwise, let's say you have a large draft pile cap, and then you don't have anything edges, and then let's say you try to become very smart, and you cantilever on this one. So you don't have any piles. You can tell the client that you save all these piles. But during construction, you cast only this part, because you have to cast this later. So in this case, it is just sitting on the soil. It will you have to resist the upthrust, as well as sometimes when you have a situation like that, when we dewater, all the soil might collapse and this might tilt. Okay, so always we need to the connect the this thing. We are doing a project in Colombo where we have only two columns. So it's about 16 meters this thing. Here we can have a beam this side, and a slab. But it won't work because you cannot cast the whole slab together. So you need to cast step by step the slab. Otherwise, it will be hanging. It will be supported on soil. So when you design anything on piles, you have to consider this as a suspended slab. So during construction, also we should not allow them to support by the soil. It cannot support by the soil. So always during construction, we should support it. So you have, we normally have a couple of diameters. Generally, I prefer about here, these are the diameters we have 600, 1000, 1200, we have 900, 1800 is the generally largest diameter that we normally use, but we have used even 2000 piles. So when you when you start when you design, you try to design most of the numbers with one pile diameter. Okay, so in a particular site, there is a particular diameter. So better then you don't have to use different tools. We can get a couple of tools. So otherwise you have to change a lot of tools. So in a site, in a pile, in a site, you try to when you design something, you try to minimize the number of varying diameters. Okay, so if you look at this one, it is mainly 1500 and 1800, few 600 piles at the edges, right? And generally when you decide place of pile, you have to have a gap between the piles. The reason is we also consider the skin friction. So if it is very close, it will interact, and then you cannot assume the same skin friction. It will not act like an individual pile. It will act like a group. So general recommendation is 2.5D D to 3D. Generally, people do 2D. Sometimes when we don't have space to put the piles, we make it 3D. I'm not going to talk about pile raft today because it's for a very multi-story buildings for pile raft, high-rise buildings. So there is option called pile raft also. Where you put a smaller piles, number of piles, and you use the pile and the raft together. So the theory, the thing is, if you can, the trick is you try to minimize the number of piles. So if you can, let's say you use a larger diameter pile to take that load. that you have up two options. You can have smaller piles, two piles to take the load, or you can have one. So if you can have one pile to take the load, that is a better option than having two piles, because you have to have a pile cap and lot of pile cap will be bigger, and if you so time also higher. So let's say in order to do one pile, it will take about 1 day. Then if you put two piles, it will be 2 days. And generally, when you do a one pile very close, my recommendation is mostly you have to have within 48 hours you cannot do a close 10-meter pile, close a 10-meter pile. So basically it should be more than 10 meters. So that is also come into play if you have many piles. So here again you can see the we have the water tanks, everything in one tower, and very close to the this thing. The idea is now in a multi-story building or a high-rise building, this is the vertical shaft. So where the people will travel, and also it is like as a man, like a spine. So all the water, blood, everything go along this spine. So similarly, most of the plumbing, electricals, all goes close to the the lift, right? We have a problem when we have this kind of thing. They has asked a lot of ducts across the lift, because those things has to come out, and then basically we have no way to transfer the load to the core, because generally you need to, in a high-rise building, you need to transfer a lot of load to the core, otherwise the core will get tension. So therefore we need to transfer this to the core. So mainly when you have all these amenities very close, you can easily accommodate, the function will be accommodated. Substructure, I will not talk much. Here the high-rise buildings we have called post-pouring strips, because there are two tall building and a short building connected together. At this point, after this building will get loaded, and this point will it will go down. We call axial shortening relative to this point, because it is not good. Therefore, it can crack. Therefore, but normally we don't connect the podium to the the high-rise buildings, and we hold it until we build the whole building structure, and then we connect. This we call a post-pouring strip. So let me go forward. These are some of the details. Now, again, I'm talking about this. This is a transfer level. So most of the time, the parking and the apartments are different grids. So you need to have a transfer level. So transfer is not a good option, because your load transfer will be varying. Therefore, it is a very costly affair. It is like having two foundation. You have foundation here, you have foundation here, and with respect to earthquakes also it's not so good. But if there is a demand, you have to design. So generally, what we normally like to do is, now there are so many options. We can have a very thick concrete plate, or we can have beams on the wall, under the walls, or here what we adopt is called a hybrid system, where now we have main beams connecting to the core, and we have secondary beams at a lower depth, and then we have like 500, depending on the stressors, to capture so we can reduce the concrete volume, because most of the time most of the people do is they put a very thick graft, but it will I will show you. This is what I was talking about, where you have the main beams supporting, and then you have this secondary beams supporting the this thing. So it is very nicely done in our sites. So we have economized because most of the time this building the designs are challenged by the contractor as well as the client, and also there are always reviewers. We need to be very economical if we are to win the project. So you can see this is a 40-story building. There are the beams height is around 2.5 meters. Currently there is, and also I like to have this seamless. Now here, what we did was, like, you have, if you want to drop, you drop like that. All walls. This is much stronger slab than this slab. Okay, so you see, then there are no beams inside. You can run the services. You can reduce the flow-to-flow height. Okay, so contractors love it, and the construction time is only 4 to 5 days per floor. Okay, you can use aluminium formwork when all the walls are finished. And other slab options, we can have beam slab option. You can have a large main beam and secondary beams, and reduce the slab thickness to around 125. So most of the Chinese like this option most of the time, because time is not a major issue with them, because their labor efficiency is very high. So even flat slab and this one, there's not much time difference. This is what I want to show you. We have to allow holes in the, otherwise, otherwise if you put this, if we say we cannot give this hole, mainly what will happen is this duct has to go like this, and your ceiling's height like that. This is a PT beam option. PT beam option. There are two things I want to tell you about PT. Post tensioning. It's very popular in Colombo now. When to go to PT? This is what, and what to do post tension. So most of the time, if the spans are more than 8 meters, if you go to post tensioning, you can reduce steel. How do you reduce steel? When the spans are large, let's say 10 meters, you need to have a larger beam depth, right? So due to the, because of this beam depth, due to the dead load, you will have deflection, you will have bending moment, etc., etc. So what the PT does is, mainly what when we do the post tensioning, what we do is we balance the dead load. We balance the dead load. We balance about 80% of the dead load. So only the live load has to be compensated with non-PT steel. So that is how it works. So with that note, with respect to the labor cost in Sri Lanka, if there is no height restriction, PT slab is uneconomical if the spans are less than 8 meters. Okay, so we don't do things for fancy reasons. If there is a particular reason, yes. And the other thing I want to tell you is, now let's say if it is a apartment building, and now say you can even post tension slabs, you can post tension beams, you can do anything, but you have to be wise. So generally, if I am post tensioning, I only post tension the beams, and we do not post tension the slabs. The reason is people want openings, people want changes to the building, right? In that case, we cannot do with post tensioning. When you are doing the post tensioning, of course, you have to mark. Now, recently, one building, uh, one building, it's post tension, slabs post tension, beams post tension. Then after that, only we came in because the client thought structure engineer is crazy, and then that is a car park floor, and the car park floors, you don't have covers, the water comes inside. So what so the client called us and said, now water is in, then the client, and it will go to the car lift, and car lift people says now we can give, because the water comes inside, we cannot give a warranty, and the owners cannot go use the car lift. They're all, it's a big crazy situation. Then we suggested to put some holes to take the water out, but we cannot take the put the holes. We don't know the where the tendon are. So those are the issues. So when when you're in the scheme design, you have to think all these situations. Otherwise, now this is a post tension slab. There is more than 10 meters. This is near the SCC building. You can see a 20-story building. More than 10 meters, the beam depth is only 450. And by that, we can reduce the flow to flow height. It's an office building. Of course, this is post tension in both directions, slabs and the beams. So, and flat slabs is another option. Generally, underground car parks, you don't need a lot of space. For car parks, we need only 2.4 for the car parks, clear space, including basements. So mainly, if we do in a basement, most of the time, for basements, what we normally do is a flat slab, so that the services can go through these corridors, and we can reduce the slab. And by doing that, we can reduce the height that we dig. It's a huge advantage to the owners. This is a flat slab. You can see how easy that you can put the pipes, you know. So very easy to do the pipes. This is office building, a flat slab, not PT, normal steel. And also the ramps. I always like to have clean surfaces. You can easily put some beams. Now here, this is, if you look at this ram beam is the beam that supports the ram. So ram wall is supporting the ram. So it does the dual purpose. So try to, so otherwise you can put a beam here. All these mixed conceptions, all we have to clear. This is one of the purpose that I'm sharing my knowledge with all of you all, just to clear these misconceptions. A lot of people tell a lot of things, and then people follow that, and finally the job goes to a foreigner. Okay, so the new building type is modular, right? Uh, everyone in future, all of our engineers will be working in factories, not in the sites. Sites only we will have only some concrete work for the course, and most of the people will be, and we will be finishing the building within couple of days, not months. Okay, so this is a module. It can be made in China or made in Sri Lanka or anywhere in the world. You ship it, you pack it. All the toilets, everything you can will be toilet pods. You don't need any. So because mainly, or maybe designed by AI. So I have been to these kind of facilities. It's a very simple facility. If you are an entrepreneur, try to focus on this kind of construction. I think we can we can uh, we can save the. I mean, we can provide the housing requirements in couple of months. See, and also we have to teach the people because who has been used to the brick and the mortar, so that we should be we can we with this is the future of the building technology. So there should be huge educational acceptance criteria work to be done, and definitely this is going to come. So look at if you look at this, this is a normal site. What happens is building construction we can do parallelly off-site, and there's a huge time saving, huge cost saving because of that. and high tech, very low problems, and you can get a house within a couple of days. Okay, so the last chapter is about presentation of calculations. This is very important. Uh, Now, I don't know about the Jaffna Council or the East Council. Uh, Here, we have to submit calculation to the Colombo Municipal Council, and every drawing has to be signed by a chartered engineer. And structural engineers are categorized for 4 stories, 8 stories, 12 stories, etc., etc. So calculations are necessary, and in future it will be mandatory. And mainly when we design something, every time it will be checked by another person. So basically, when you think about calculations are not for you. It is for another person to check. This is to check. Maybe your superior, maybe your counterpart, maybe client, maybe contractor. We need to, this intention is to provide something to justify to others. So this is a typical calculation I want to show you, produced by our company, where you need to have a project, and the person who has prepared it, and there should be somebody to check the date and the page number. Very important. Very important. When you go to the next page, the page, it's very important. Okay, you have to have some hand calculation, not everything by the computer. And first thing, you have to tell what are you doing, and then you have to draw the schematic, and then provide some sections so that the other person understand how do you calculate, right? And how do you get the dead loads? See the handwriting, very professional, right? And this is done by engineer Dilni Hettiarachi. His handwriting is immaculate. All the signs, the equal signs are in line. Okay, so when you that from the engineers are judged by their calculations and drawings, the sketches. So the young people do not underestimate this, the importance of this calculation, hand calculation and sketches. So most of the people try to do with Excel, and it is not appreciated by the most of the seniors. Seniors knows how important this thing. And then you do all the calculations and you get all this, and please draw this sketch with a section. In my office, first when they do this, and then we check, and after we sign, it goes to the draft person, right? So this is the practice that we do. So this is what we wanted to share. I know some engineers give sketches in the bus ticket, right? So this is actually degrading our. The calculation should be very accurate. You cannot the final sketch may be different, but calculations. What is W1, right? W1 is the weight calculations. What is the P, right? Everything properly calculated. Span 1, span 2, nicely calculated. So very important that you properly calculate and then you can whatever from the maybe you use a analytical program or you use Excel or whatever. You draw the bending moment diagrams and you multiply and then finally the sketch. If you can do this small thing, you going to become a very good engineer. Okay, so the details we will look at later, the corner details. That those are things that we can easily adapt from guidelines. And in a calculation, first is the basis of design, BOD. This is what I did earlier. So we have to tell the checker what is our basis of design. What are the codes that we have used? Let me zoom. What is the basis of design? Okay, and then the material properties, design loads, the wind loads, earthquake loads. So basically, we will have to tell them this is what we have taken. Then the load combinations. This is only an example. And design criteria. What are the deflection criteria? What is the deflection criteria? What is the crack width criteria? What is the crack width for water retaining? Then design under wind loads. What is the loads that we have taken? Earthquake loads, and we discuss about this the performance of the buildings. We have to tell. Okay, this is my criteria. If if they don't agree, that's a different question. Then this is your architecture scheme. Then you can have your structural analysis model based on the whatever this, and then you present your modes. But I told you first mode is translation, second mode is translation, third mode is rotation, and you can put all that data here. Don't try to fudge. You try to be honest as possible. Put everything, because he's going to ask you the model and they are going to check. Honesty is the only policy, right? Don't try to cheat. Don't try to change some numbers. You can easily change the numbers, but if they find out you have made a mistake or you have maliciously changed, your integrity will go. And then you give the outputs, necessary output, right? The deflection, what are the allowable? So very easy to check. And most of the time, the checker will do his hand calculations and check whether your calculations are correct, right? Rough foundation. Give the borehole data. Don't let him look at it. Give him the information. And basically, when you do a column design, so use now most of the time based on the area, the column loads are similar or very close. So you can say, okay, this is C1, all this has very similar load. C1A, this is how I selected. This is how I rationalize my design. Otherwise, if somebody asks make C1, C2, C3, C4, that means he has never done a design, right? So basically, you can categorize. Okay, this is what I'm going to do. This is how I did. You try to tell a story to the checker. That this is so. If it is logical, he will because right. And then you get a strip. You show this is the strip, and these are the column loads, and this is how I loaded, and then these are the outputs. Very simple. You just cut and paste from the this thing. It would be very clear. And then you say, okay, these are the maximum values, and then based on the maximum values, I have provided the reinforcement. Okay. And there are many Excel sheets you can easily get from the and then you put these numbers. You don't need now these days. I think nobody do hand calculations with respect to this. Uh, Basically, put all the correct values. We look at this. We look at the cover. We look at whether you have put the correct values, and then we check whether there are any and whether the support conditions are given. So you just have to paste it and then summarize the data. And this is the soil pressure. Basically, I would like to see actually the soil pressure under the draft. Okay. And then you can also see the bending moments, and based on the bending moments, we can get the reinforcement requirement. You can see it's very simply reinforced. You can see that there is a bar here. There are the main bars and additional bars for that. Simple, detail, make it simple. Make others' life simple. Your life will be much simpler. Here also you can see when you are cutting the bars, very important you don't waste. You know, if you are using 12-meter bars, you cut it. If you cut it to 6 meter, 6 meter. If you cut it to 4, 3 meter, 3 meter, right? Or if you 12-meter bars, you can cut it to 3, 4 meter, 4 meter. So don't put because code says 0.3 L, 4.1 or something like that. Don't make that mistake. There so a lot of wastage in that. So though that you will get with the with time, with the experience, and these are some of the pile calculations where here you find uh, the skin frictions, and we the with the different borehole capacities, we get these pile capacities, and we have looked at different boreholes, different pile capacities, and generally we adapt the least ones in the recommended capacities. So I told you that day to then you put the reinforcement, and these are some of the drawings. And with respect to the walls, we can have stress diagrams, and from the stress we can calculate the reinforcement requirement, and then we provide the reinforcement requirement, or we can use all the basically we can export this to CSI call and see whether the capacity exceeded based on the 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 stresses or the bending moment. So the columns, you have to look at all the combinations. We can put everything into some program and see whether the capacity is exceeded, or you can there are first you can put the reinforcement and mainly what you have to understand is, now if you look at a book, any book, you have only 4 bars, but in reality you have many bars. So basically, when you arrange the bars, if the same reinforcement you arrange like this will be have a higher bending capacity because it is very close to the corners, right? Than this. So you might be if you have an issue, you have to change the bar position and check the capacity. So there are many softwares to use and generally use the code rules where it says the link diameter should be based on the vertical bar diameter. The link spacing should be based on the thing. And for earthquake, we have different rules. So based on the rules, prescriptive rules, you have to detail. This is transfer beams, and here when you look at a slab, so you have different loads, and then so we have to show the different loads, and then we can look at the bending moment of the beams, and in one sheet we can for the bending moment we can calculate the reinforcement, top reinforcement, bottom reinforcement, shear force, and then you provide the details. So generally I want to highlight two things. One is at the corners I normally put a U-bar. So basically when you detail, we need to consider now say for instance if you detail this one, these are the main beams, right? These may be secondary beams. So the these bars, now these bars should be going up, and then these bars we need to show to the contractor it is going in between, right? So everything we have to look at how to do it, and then the link diameter of this will be less, and it will have a higher cover to that beam. And so, and corners very important, how to detail. Sometimes we need to properly think about it. If it is a simply supported beam, let's say I will tell you a simple rule now we normally put. So this is 100%, here 100%, here 50%, here 20%, here for earthquake 50%. If it is if you are not designed for earthquake, 30%. So likewise, we can have a small rule. So let's say this is 225s, then this will be 220s, this will be 216s, this will be 225. And the other thing is, if you are redistributing, don't redistribute more than 15%. Better to redistribute so that you can reduce the reinforcement and balance the top and the bottom reinforcement. Otherwise, most of the time, most of the engineers do what I see is you analyze as a subframe, you get very high bending moment, you don't redistribute, you put lot of reinforcement here, very little reinforcement here. But when you do that, there will be cracks in the beams because you have less reinforcement. Best thing is to redistribute this, and generally when you redistribute 15%, the reinforcement here and here will be the same. Here and here will be the same. You can do it and see. Transfer flows. So transfer flows is very complicated. You need to have software to understand because there are so many load combinations we need to look at. So we have to look at the deflections. Generally, I look at the deflections for service loads, and you have to look at different load combinations and get the maximum and try to put the reinforcement for that. So today the design is very interesting because you see a lot of interaction between the software and us. But use the software wisely, and if you use software wisely, you can enjoy your. Because the good thing about software is you can try a lot of options. Thank you.
Thank you very much, sir, for your valuable presentation. On behalf of the members of the IESL, I would like to thank for accepting the invitation and spending your very valuable time to share your knowledge and experience on the field of structural engineering among engineers. It was a very useful session and successful session with more than 200 engineers participating from different sectors like public sectors, private sectors, and from very senior engineers to junior engineers. You will manage the session to cover all of their expectations. Thank you very much again for this great presentation. Without taking much time, I ask IESL chairman to continue the session. Before that, we can allow participants to ask questions, and also participants can give you reflections with respect to the sessions, and you can give the reflections and the feedback. It also will be very useful for us organizing the similar events in the future. Thank you very much for the resource person and the participants. This is the time for questions.
Thank you, Gilbert, for the opportunity.
So I have the small doubts.
Yes.
Yeah. So when we design this PT beam design for the beams and slabs, so
Yeah.
actually some contractor or some client want you utilize the 100% column stiffness to transfer the PT beam bending moment to the column. So actually, how can we ensure using in ETAPS or some other softwares whether this 100% column stiffness is using in this PT beam design?
Yeah, it's a multi-story structure.
Even this, just because even the just a single structure, but the connection area. So how can we ensure that the 100% column stiffness is utilized for the PTB movement transfer to the column?
It's like this. Generally, we do not transfer the moment to the column because we only balance the dead load, right? So basically, did you know, say for instance, we only balance the dead load. We do not balance wind load or anything like that, right? So we only balance the dead load. So we dead load is 100% sure load. We will balance the dead load. So if you do not take the tendon above the center line, there won't be any moment to the column. Due to the there will be a small additional moment due to the shrinkage and the creep effects. So generally there won't be much moment due to the column due to PT. There will be a small additional moment only. You got my point?
Yes, sir. Yeah. Okay. Thank you.
So let's say you have only 2 columns. Now we have a similar problem. What I told my engineer was only balance the dead load to wind load and the hogging moments. You put non-PT steel. Okay. So
Yeah.
basically, it will reduce the deflection.
Because I faced one project, they requested to utilize the 100% column stiffness. That's what I asked. So how can we ensure? Sure. Yeah. Okay, thank you, sir.
If anybody don't have any question, we can close the session. Thank you, sir, for sharing your valuable experience and the knowledge to the Vadakkin chapter engineers. And you told me engineers are judged by calculations and their drawings. It is a good, valuable word to the engineers. Now the official vote of thanks will be given by Engineer Moshida, the Vadakkin chapter executive committee member.
Good evening, distinguished resource person, Chairman IESL Vadakkin chapter, and dear participants. On behalf of IESL Vadakkin chapter, I feel immense pleasure to propose a vote of thanks. I want to express my sincere gratitude to our resource person, Engineer Shiromal, Fernando, Chairman of Council on Tall Buildings and Urban Habitat, and Managing Director and the leading structural engineer in CSE Consultants. He has spent his precious time from his busy schedule to present this valuable session to our engineers without any hesitation or objection, even though he has the difficult time in these days. Sir, you have enlightened the knowledge of our engineers in structural design of multi-storied buildings, especially with sharing your broad experience. Thank you so much, sir. I would further extend the hearty thanks to our Chairman, IESL Vadakkin chapter, and the committee members who are the pillars of the IESL Vadakkin chapter events, which have been conducted throughout the year. And I would especially thank Engineer Kiribaran for his unfaltering support to IESL Vadakkin chapter and for organizing this event very successful with more than 200 participants. My deep sense of thanks and appreciation goes to all the participants who are being here with us and attended this session with great enthusiasm. Made today's event a great success. In the end, thank you all for being with us today. Good night.
Thank you very much. Thank you. Good night.
Thank you, sir.
Thank you very much.